let's look at this from a geometry perspective. Tangrams, because remember, tangrams could be used to explore partial relationships as well as geometry. Tangrams are made up of, it's a square. We have a square made up of 7 geometric shapes. So let's think about the properties of a square. I'll just write down properties of a square. And we have a couple that are really important. Number 1, all the sides of a square are congruent or equal. So all sides of a square are equal. 2, the inside angles are the angles in a square. They're equal to 90. Each of these angles here is 90 degrees. They meet at 90 degrees. 3, the diagonal lines in a square, in any square, they do 2 things. 1, they bisect each other, meaning when these diagonal lines meet, this line segment and this line segment and this line segment are equal. So they bisect each other, meaning they cut each other in half so that this and this and this and this are equal. And they also bisect, I'll put a B for bisect, and they meet at 90 degrees, meaning they form 90-degree angles here, here, and here. Now, we can build a lot of new ideas from these 3 properties of a square. All the sides are equal, all the angles of a square, interior angles are 90 degrees, and that this third one, the diagonal lines bisect each other and meet at 90 degrees. We can build a lot of math from here. Like, for example, each one of these large triangles has 2 sides that are equal and has a 90 degree. Well, we call that an isosceles right triangle. So this is an isosceles right triangle. So if I find out that this side here is 2, this side here is 2 as well. Well, it just so happens that there's a square in this shape. So this square, we already know that all sides of the square are equal. That means that this is a 1, this is a 1, this is a 1, this is a 1, right? And if this is a 1, this is a 1, this is a 1, that's great. This is a 1 here. Well, then we also know that that little triangle has a 1 as well. So guess what? Now we have the dimensions of the little triangle, 1 by 1. They're half the dimensions of the large triangle. We have the dimensions of the square, 1 by 1 by 1 by 1, or half the dimensions of the large triangle. We even have the dimensions of the parallelogram here. You see that parallelogram? It has the same height as the small triangle and the square. It shares that same height of 1, and it has that same base, same size as the square as 1. So if we were trying to evaluate a parallelogram that's formed, well, this is a terrible drawing of a parallelogram. We know that it's 1 by 1. Well, this is all good to know if you have an awareness of these shapes. This is just nice relationships to sort of see, and just using the geometry to help you see them. The area of that large one, whatever it is, we would find that it is 4 times the area of each one of those little triangles. 4 little triangles fit into that. So we could say here that this one represents 1/4 the area of the large one. We'd find out that the square, which is made up of 2 triangles, we could say the square, whatever the area of this is right here, we could say, you know what? The area of that square is 1/2 the area of that large one. Of this triangle right here, the mid-sized triangle, which is made up of 2 smaller triangles, we would find out when we did the area calculations out, we would say, hey, guess what? The area of that shape right there is what? 1/2 the area of the large triangle. Even with the parallelogram, which is made up of 2 little triangles, we find out that if a little triangle is 1/4 the big one, we'd find, I don't want to do that. We'd find out that the area of this one right here is 1/2 of the large one. Now, this is a nice awareness to know, because if you're ever doing a problem and they tell you, hey, you got a tangram, and this one has an area of 64. Well, if you know that the large triangle has an area of 64, well, then we can quickly derive the areas of these other shapes just because we have an awareness. Like if this one's 64, the mid-sized triangle is going to have an area of what? Well, it's half of 64, 32. Or if the large triangle is 64, well, each little triangle is a fourth the area of 64, or 16. Or if we're trying to find out the square, well, the area of the square is 1/2 the area of that large triangle, or 1/2 of 64 is 32. And even the parallelogram, because we have this awareness, we know that the parallelogram is half the area of the large one. We know that 1/2 of 64 is 32. And this works for all sorts of numbers. So it doesn't. You can practice this using all sorts of numbers. Like usually numbers that are multiples of 4 work the best. So if we're doing this and we didn't want to use 64, we could answer the same problem by using 32. Using 32, well, everything would be modified a little bit. If the area of one of these shapes here is 32 units squared, this little triangle, which is 1/4 the area of this large triangle, would be 1/4 of 32, or 8. If this has an area of 8 and this has an area, it's 1/4 of 32. Or the square would be 1/2 of 32, or 16. And the square, the mid-sized triangle, and the parallelogram all have 16. We could even use other numbers. So if we didn't want to use a 64 or 32, we could do 16. If we said that this shape here has an area of 16, well, then that would mean each one of these little ones would be a fourth of 16. So if this is 16, this one here is a fourth of 16, or 4. And if this is 16, and this is the square is 1/2 of 16, then that would mean that's 8. And so on and so on. Okay, let's just clarify some of the things that we just mentioned, just pulling it out a little bit. Hi team, this is Chris Abraham from GOHAcademy. I hope you enjoyed this video. If you like it, press the like button below or subscribe to our channel. We're going to do more of these videos to support teachers to prepare for their teacher certification exams. If you need additional help, check out a GOHAcademy workshop. Go to GOHacademy.com and you'll see the workshops and webinars and tutoring available for teachers that need additional support. All right, thanks so much. Have a wonderful day, team. Take care. Bye-bye.